Welcome to our Advanced Higher Chemistry lesson on alcohols. So what we'll be looking at in this video are a reminder of primary, secondary and tertiary alcohols. We'll also be looking at the reactions that form alcohols and the reactions that you can do with alcohols. So when it comes to making alcohols, the first thing, first reaction you can do is nucleophilic substitution of haloalkanes. So you take your hydroxide ion, which must be dissolved in water, and you react it with a haloalkane and you do the substitution. Now remember, you could be asked in a question like this which mechanism it occurs by, so you need to know about your SN1 and your SN2 reaction mechanisms because they can be related to this nucleophilic substitution. The second way in which an alcohol can be made is a reaction you learned in National 5, the hydration of alkanes. Now, the hydration of alkanes is an acid-catalyzed addition reaction. So what you have is your water reacting with the alkane, and because the alkane is not symmetrical in this case, you can get two possible products. So where you have an alkane, remember the hydrogen will add on to one carbon, the hydroxyl will add on to the other carbon, or you can have them switched around. So if the alkane is not symmetrical, you will get two different isomers forming. This is an example of an electrophilic addition, and when we discuss alkanes, I will show you the mechanism for this reaction because it is quite a complicated mechanism occurring in 3 individual steps. While there are 2 possible products, one of them is favoured, and again the mechanism will show you which one of those is favoured. The third way in which we can make alcohols is by reducing carbonyl compounds, so either ketones or aldehydes, to their hydroxyl groups, so the reverse of oxidation. Now, aldehydes and ketones can be converted back to primary and secondary alcohols respectively. So aldehydes to primary, ketones to secondary. The reagent used in these reactions is something known as lithium aluminium hydride or lithium aluminium tetrahydride, the formula for which is LiAlH4. In Advanced Higher, all reduction reactions in Unit 2 will use this lithium aluminium tetrahydride, so do learn that name and associate it with reduction. The lithium aluminium hydride must be dissolved in ether because the lithium aluminium hydride can react with water and any other solvent that's capable of forming hydrogen bonding. You do not need to know the mechanisms, you just need to know that what the LiAlH4 is doing is giving hydrogen ions or giving hydrogen atoms to the molecules. And so the carbonyl group forms an OH, and the carbon, which was part of the carbonyl group, will also gain another hydrogen. So when you do reduction reactions, you will see the gram formula mass increase by 2 because you will have gained 2 hydrogen atoms. The reactions of alcohols. So first one of these you will have seen in the video on monohaloalkanes when we looked at substitution reactions, and this is the formation of alkoxides. Alkoxides are used to make ethers, and when an alcohol is reacted with potassium metal or sodium metal, we get these alkoxide ions. And an alkoxide is just an alcohol where the hydrogen part of the hydroxyl group has been removed to give an O- ion attached onto the alcohol. So you go, for example, sodium plus ethanol forms sodium F oxide, and you'll get some hydrogen. Another example here, potassium plus butane, is that butane 1, 2, 3, 4, yes? Butanol or butanol would form potassium butoxide and some hydrogen. Now, these reactions can be considered a redox reaction because you're forming ions, or they can be considered substitution, in which you're substituting the metal and the hydrogen atom. But you do need to know this reaction. If you want to form an alkoxide reaction, you react an alcohol with a metal. Dehydration is the second reaction of alcohols that you need to know, and this is your way of turning an alcohol into an alkene. Now, this reaction is very similar to elimination, but it's called dehydration because instead of removing H and a halide, you're removing water from the molecule. The mechanism you do not need to know, but you do need to know the chemicals that can be used to do this reaction. So dehydration is just the reverse of hydration, and if you've got an alcohol with two neighbouring carbons on it, there will be two possible products that can form. The two methods of doing it, the first one is to pass the alcohol over hot aluminium oxide. That catalyst, that hot aluminium oxide, is something you need to be able to say. The second way of doing it is to treat the alcohol with concentrated sulfuric or phosphoric acid. Those concentrated acids have dehydration properties. They like absorbing water, so they will actually physically remove water molecules from alcohols to produce the alkanes. The third reaction are oxidation reactions, and this you know from higher. The only additional item on this is that you used to only need to know two different oxidation reagents. Now you need to know a third one, and you need to know the color changes. So the three ways to oxidize an alcohol to an aldehyde or ketone are to use hot copper oxide, which goes from black to a copper color, a reddy brown, acidified dichromate, which goes from orange to green, and the third one, which is new to advanced higher, is acidified potassium permanganate, which goes from bright purple to colorless, and it's again acidified. Remember, if you're ever asked why does it need to be acidified, it's because it's redox reactions to provide the H+ ions. So remember, when it comes to oxidizing alcohols, the type of alcohol will determine what type of oxidation can occur. Primary alcohols will oxidize to aldehydes and then may go on to oxidize to carboxylic acids. Secondary alcohols will oxidize to ketones, but tertiary alcohols cannot react. So no matter which of those three reagents you add to a tertiary alcohol, no reaction will happen and no color change will be seen. The next reaction that alcohols can do is esterification. So from higher, you know how to make esters. You react alcohols with carboxylic acids in a condensation reaction. So two molecules join together to make one large molecule and one small molecule. At higher, it was always water being that small molecule, but you'll see on the next slide that it does not have to be water. So we've got our two types, or maybe it's on this slide actually. So you can react an alcohol with a carboxylic acid. For this reaction, you need a catalyst, you need strong sulfuric acid, and you will form your ester. Remember, when it comes to naming the ester, the first part of the name, the bit that ends in -ile, comes from the alcohol, and the second part, that bit that ends in -08, comes from the carboxylic acid, and you will produce water. In a very similar reaction, you can instead react your alcohol with something called an acid chloride. Now, an acid chloride looks very similar to a carboxylic acid, and the only difference is that the hydroxyl group has been replaced by a chlorine. Now, doing that just creates a much more reactive molecule that does not require a catalyst and doesn't require the same degree of heating. It's also a much more clear-cut reaction where you should end up with a much purer product than compared to using the carboxylic acid. In this reaction, you still make an ester, and that ester gets its oxygen from the alcohol. In this case, it is still called a condensation reaction, but you can see you're not making water. What instead you're making is hydrochloric acid, because you have removed the H from your hydroxyl group in ethanol and your chlorine from your acid chloride, and when they reform together, you make hydrochloric acid. So this video has been a go-over of the few different ways of making alcohols and then a few different reactions that alcohols are involved in. Alcohols are one of the most versatile chemicals within synthesis, so it is important that you learn all of these reactions and the chemicals involved, because it is very likely that one step within a synthesis reaction will involve either making or using an alcohol.